Thank you for coming all. Yes, Russellization, the sustainable future of microbial inactivation. Jaco Baron, as I was introduced. I'm going to give you a brief introduction. What is it? What does it do? And then Harald from FrieslandCampina will share his experience with our technology. Russellization is a UVC treatment of liquid food. UVC of treatment of liquids has been around for a long time, decades, and is until today still used in transparent fluids like our drinking water. The technology has evolved, like with many technologies, and back in 2017, our founder and also inventor of technology, Rasmus Mortensen, you see here on the left, on the right you see our current CEO, invented a way to treat opaque liquids with UVC, which was not possible before. What is it? We are treating both transparent and opaque liquids with UVC and inactivate microbes. What we affect is bacteria, yeast, mold, etc. But what we do not affect, or barely affect, are the nutrients in a lot of food. Like proteins, like vitamins, enzymes. So we don't affect them at all. Some minimal. Yeah. What's the benefit? You can imagine traditional systems like pasteurization, filtration to deal with microbes use heat or a lot of energy. We see a dramatic reduction in energy usage, 60 to 90%. Same for water, because we don't use heat, we don't have fouling on equipment. We can run for much longer. Minimum CIP requirements, so we save a lot of water as well. And because we don't affect nutrients like proteins, we see a yield increase 3 to 10%, and also we have no retentate like with filtration, so yield increase of 3 to 10%. What does UV do? We basically damage DNA, so microbes cannot reproduce, hence we kill them off. How does our system work, our technology work? We have a UVC lamp that emits UVC light, typically between 200 and 280 nanometers. We have a transparent coil which carries the fluid. So lamp and fluid are separated. In that coil, we create turbulence, so we ensure that all the fluid and therefore microbes get exposed to UV light. So that's the way to deal with opaque liquids, that we ensure microbial inactivation. Some products are more sensitive to UV than other products. So what we can do is apply a filter. I mean, see it as a sunglass basically. Yeah, so it's not a physical filter, it's a sunglass for UV light. We then filter out only the UV light at 254 nanometer, which is the wavelength that is needed to kill microbes. We are not a startup anymore. Like I said, we have been around for a while. We have established ourselves. We have developed a whole range of capacities for any producer basically. So if you take the most difficult product that can be treated, we can treat at a minimum capacity of 150 liters per hour. Also we can use it as pilot plant actually. Up to, if we take a relatively easy product, we can go up to 200 or 380,000 liters per hour. So we have something for every product, for every producer. So. What industries have we been active in and do we have experience? I mean, we have different categories, dairy, processed water, fermentation, and we call it other, a lot of other liquids. In the meantime, we have screened on UVT, UV transmission, and viscosity. We have tested over 1,400 products, and we have validated products either pilot scale or commercially, over 300 products. So it's not new. It's there. It's available. A lot of work done in dairy. but also you can see on the right a lot of different other liquids. Blood plasma, juices, enzymes, plant protein, basically a whole range of fluids that we can treat. Harald will, as an example of our dairy category, so for dairy, share now his experience that FrieslandCampina has done or has gained with our technology.
Yep.
Thank you, Harald.
Okay, you can hear me? Okay, good. So my name is Harald Schuten. I work for FrieslandCampina and I'm a senior scientist preservation technology, meaning that is everything between raw materials and end products and how do we design our processes to make sure that we make microbial safe food and have a specific shelf life. And that is covering actually the whole portfolio of FrieslandCampina. So, as you might know, FrieslandCampina mainly know, we feed millions of people in the world. And actually we say nourish by nature. And nourish by nature means that milk has a lot of good components in them, which might have health benefits, and we want to keep that. How we do that? As FrieslandCampina, we own the whole chain. So from the farmers, raw materials, into end products. And so we have also the opportunity to keep the right components that we have in our raw milk towards our end products. That can be milk, that can be powders, that can be infant formula, that can be anything. So like I said, so milk has a lot of components in them. So proteins, lactose, fat, vitamins, minerals. And if you want to make dairy products, you need to heat the dairy products. You need to heat the products to make sure that the microbiology is inactivated and you have safe products that nobody gets ill of the products will not spoil within the shelf life. However, there is a bit of an issue here because some of the products, some of the components which are in milk are heat sensitive. So if you overheat them, which you might need for shelf life or other characteristics, you actually destroy them, and mainly it's within the proteins. So milk has a lot of different proteins in them. Part of the proteins are heat sensitive, and especially these types of proteins that are heat sensitive, they are important for us because they can give potential benefits to our products. So that's actually what it's all about. That is my work. How do we balance on the one side microbial reduction, and on the other side keep our heat sensitive components intact. That can be for the whole range of products that we have. And this is a challenge. So we actually always need to use pasteurization. So we always have a heat treatment in our processes. However, you can imagine if you want to make UHT milk, you have an extra heat treatment to kill off all the spores. So we are looking, especially in our research, to technology solutions that can help us to reduce the microbiology without using extra heat above the pasteurization that we use. So, and then I think it was about, we just discussed also with Lyras about 3 years ago, yes, in our search for these kind of technologies called in the field, non-thermal technologies, I came across Lyras. And I was actually triggered because Lyras presented itself about reinventing pasteurization. Now, I just told you we don't want to get rid of pasteurization because of legal, we need to legally apply to that. However, we have more microorganisms to inactivate. So I was quite triggered because there are also other solutions for non-thermal preservation, like high pressure, pulse electric fields, but these all have some disadvantages. Of course, this also you can think of disadvantages. However, we thought at that moment this might be an opportunity to really step into this non-thermal processing. Oh, one back, sorry. So what we actually did, I said to my boss, dear, we have to step on this train. Let's try to, in our innovation center in Wageningen, to rent equipment from Lyras and just try a lot of different types of dairy streams. So you have milk, you have whey, you have brine, you can think of a lot of things. So we tested a lot, and actually based on that, a whole program has started on the use of UVC within FrieslandCampina for a search for typical applications. So here you can also see that. So we actually we first rented one and then we bought one, a Polaris pilot plant equipment. On the left, of for you on the left, that is for instance in our Wageningen pilot plant facilities. Then we just get a container of some kind of product somewhere from our supply chain and treat it with UVC. And here's another example. What we also use the Polaris for is go with the Polaris to the supply chain, somewhere to a factory, anywhere in our production area, and link it to the production line to also test under production conditions. Now, what do we find? I apologize. I cannot tell a lot, but I want to trigger you something because we as FrieslandCampina think this is an interesting technology that also other companies should adapt. So first of all, I look to microbial reduction compared to pasteurization. So on the left you have a graph showing fresh milk, UVC treated milk, pasteurized milk and pasteurized milk plus UVC. And it shows the microbial reduction. So how much log of microorganisms do we reduce using either UVC or pasteurization? So fresh milk, of course, nothing, that is our base case. The second one is UVC. Actually, in this typical example, about 3 to 3.5, so 3.5 log, 4 log more. So 4 log, that is, I always have to think, 10,000 microorganisms reduced. If I look then to pasteurized and UVC, I actually see the same reduction on our total plate count. So that's the whole pool of microorganisms that are there. But also, what we found, if we pasteurize the product first, oh sorry, there's a typo here, my apologies, and we then use UVC, we have actually an extra inactivation above that. So meaning that we also inactivate other types of microorganisms which cannot be inactivated by pasteurization as such. Then the other important point, because we do not only do this that we can pasteurize, of course, or that we can inactivate. The other part of the balance is heat-sensitive native proteins. Do we keep them? So in the fresh milk, of course, we have 100%. If we pasteurize, for this specific example, we go back to 75% of that. It seems small, but if this is a very valuable ingredient or a very valuable protein, then 25% reduction is really a lot. If you UVC treat it, yeah, it looks a bit the same, but actually, if you statistically, there's no difference. And if you pasteurize and then UVC, also there's no difference. So for us, if you remember the balance, this is the balance where we are looking for. And this is also linked, because for FrieslandCampina, we do not do anything just, we don't try it. 10 minutes? Okay, good. Also, the acceptance of the technology is important. So it's a new technology, and we cannot just do it. So I already said we cannot just change the pasteurizer for UVC, because that is not legally allowed. But what if we treat a pasteurized product with UVC? Can we do that? So there's a lot of going on in this world. For instance, this is an example that I got is a bit linked to the example I just showed from the graph. There's a novel food application for the use of treating whole or half full milk with UVC, pasteurized whole or half full milk with UVC. So also from a regulation point of view, there's a lot of going on. Another part, which is also interesting for us and also dairy companies in general, is the production of whey. So whey comes from the cheese, and from whey you make ingredients further, so protein ingredients. What we see here is we played around a bit with the Lyras system. So Jaco already told there are coils in the system, and they have coils of different diameters, different flows. And you can play around with that a bit. What we did here is the blue one is a 5 mm coil, so 5 mm tube. And we treated thick whey that has 20%, 26% dry matter more or less. The red one is a 7 mm coil, also 26% dry matter. And the blue one, or what is it? Oh, sorry, the gray one is 10 mm coil and 5% dry matter. And you can see microbial inactivation, just as in the same graph before, you can see differences. And there we play around with, okay, what for FrieslandCampina and for typical applications can be the right processing setup, and also to optimize the technology. Also here, based on a lot of data, we measure also native proteins left, and we each time keep repeating this to make sure that we do not destroy these components that we actually want. Another thing also related to the cheese making is the brine of the cheese. Actually, the brine, so you salt the cheese with the brine, but the brine can be infected by microorganisms, and you want to control that. So actually we found out that the use of UVC for brine is very effective and can reduce the microbiology sufficiently. Okay, so for FrieslandCampina, this is still research, so we are really in the research phase to see where are our applications. But our conclusion is that UVC, or racialization, is a promising alternative to pasteurization and has the potential to become mainstream inactivation technology within dairy or otherwise. And why is that then? So if I compare to heat treatment, we can reach the same things as pasteurization. If I go to sustainability, like Jaco showed, also we have the benefits there. Product, we can have product benefits, keeping components intact. From a CAPEX or OPEX point of view, it's also comparable or maybe better. But why don't we do it yet? That is really about this part. So you have to realize, also Lyras realizes that you have to compete to a technology which is there for 150 years and where we rely on for food safety reasons. So we need to build up knowledge and gain knowledge about that to make sure that we can use it in a safe way, I think. Oh, wait, this was not mentioned. So why are we doing this? Promising technology. How does it work? Inactivation by UVC. And it's an upcoming technology, and we are interested in that. What do we still do in research? Process optimization. Also check if there aren't other effects. So we want to keep the proteins, but does it do something else, which we don't want? We want to check that. And a very good point, which is also useful for Lyras, is the acceptation of the technology. That can be regulatory, but that can also be from our clients, from our customers, etc. So, and that is, I think, so, yeah.
Yeah, thank you very much, Harald. I mean, what I hope we have achieved is that we've given you a brief overview on the technology, how it works. Relatively simple, of course, but the application itself, is certainly a dairy a bit more tricky. But I think, Harald, you've done a lot of work. I think you're confident with our technology. So I hope I've been able to convey that message. And I mean, see you at the booth if you have any further questions. Because there's a lot more to be talked about, of course, about the technology and how we do it, what does it look like, etc. So thank you for your attention.
Applause, ladies and gentlemen, of our speakers.